Okay, let's start again because I think I was muted. Yep, thanks. Okay, so thanks so much for having me, Sasha, to 1511's guest lecture on games programming. And I'm really excited to talk to you about how we can take what you guys have been learning so far in 1511 and looking forward and seeing, having learned these concepts, what are the sort of things we can apply our programming skills to? And so the thing I'm going to talk to you about today is games programming. So far you've been writing programs in C using the C standard library. And the C standard library has been helping you do things like handle strings, do math operations, read in and out from the terminal and things like that. And so the C standard library is really designed to help you solve the most common problems that all software projects need to tackle. So that you don't have to, as a developer, you don't have to be creating, functions to read and write from the terminal or do the things that we're doing every single time. But to write more specialized programs, something like a game, it requires a lot of effort, and we need to use a lot of these building blocks to create more building blocks. So we need a way to create a window or draw text to that window. And that requires a significant amount of extra functions and definitions that the C standard library is not going to create, because they can't justify spending that time to create every possible function that anyone could ever require. So because it's such a considerable effort, someone else needs to build these libraries for us so that we can get developing the project that we want to develop. So third-party libraries, such as SplashKit in the case that we'll be talking about today, provide some certain functionality so that you can spend time creating interesting programs or solving specific problems that you want to solve, rather than spending all that effort in actually creating the library itself. So what is the SplashKit library? Is there still no audio? It's looking like you can hear me now. Yeah, okay, there should be audio. Yeah, cool, thanks. Thank you. Okay, awesome. Yeah, cool. That might have been delayed or something. Okay, so what is the SplashKit library? So SplashKit is actually a series of functionality. And I'm showing you sort of the documentation list there. And if we take a closer look at that, you can see there's some functionality around audio. So playing sounds, all good. Colors, databases, and really interestingly, graphics, networking, sprites, animations, windows, and things like that. These are all sets of functionality that does not exist in C or the C standard library. Taking a closer look at that, you can see within graphics, for example, we have functions to you couldn't see my screen. That's okay. So we have a series of classes of functionality available in the SplashKit library, and we can see that within those classes of functionality, we have a set of actual functions. So just like you have printf or scanf, we have draw circle. So we can draw a circle to a window, fill a rectangle. If you've got really good eyesight, you can see on the right-hand side of this list a number of functionality, and these just exist within the graphics section of SplashKit. So rather than talk about it too much, let's actually get started and create a really basic SplashKit C application. And as all of you should know, the first thing you should write in a language or a new project or a new framework like SplashKit has to be Hello World. Otherwise, the programming gods will smite you forever, right? So we need to let's build something like Hello World, but we're going to build it using SplashKit, and it's going to be graphical. So it's going to be really, really cool. So let's switch to my desktop. And we can see here, if I zoom this in a bit, I have some basic C code here that should look really familiar to you all, right? And of course, as we go, if anyone has any questions, please interrupt me and let me know. So we have a basic C program here, except at the top we have this unusual line that you haven't seen before, which is including splashkit.h. So just like any other library, there is a SplashKit header file somewhere on my computer. We're not going to talk too much about it, but we had to actually download it because it doesn't just get shipped with C. And after I include it, I now have access to a huge number of functionality that's available in the SplashKit library, right? So the first thing we're going to do is let's just open a graphics window. So there is a function within, there's a function within SplashKit called open window. And you can see here with the IntelliSensor that it takes 3 parameters, a caption, a width, and a height. So I can give it, 1511 is the name of my window. And then it wants the width, let's just say 400 by 800. Now, the problem if I just compiled and ran this is that the window would only be open for an instance, because then the immediate following line would be to return 0 and quit the program. So what we can do here is just delay, let's say 5 seconds, 5,000 milliseconds. Now delay is also a SplashKit function, so it's not something that you've probably seen before, but you've probably seen the concept of sleeping or something. So we're just going to pause the program for 5 seconds, then we can return 0. Now the way we compile this is slightly different. We're using a different compiler, but we're just compiling C code just the same as we've always done. I give it the name of the C file that I'm compiling, just as you always do, and I can set the output to be hello window. If I compile that, I can see that command ran successfully, and then if I run hello window, because that's the name of the executive, you can see here that I have this window open and it should close within a few seconds, which is exactly what's happened. So if we just run that again, you'll see this graphics window. You can see it's titled 1511. I can move it around and then it quits after 5 seconds. But that's really cool. So that's something you can't typically do in C using the C standard libraries. I've created a graphics window. And now we can start to do stuff with that graphics window. So why don't we, after we open the window, draw some text to the window. So draw text, my screen just went blank. Draw text takes a number of parameters. It takes the actual string that we want to draw, string literal. So I can just say, hello, everyone in 1511. Sorry, my technical issues all day today. Okay, then I need to give it the color of that text that I want to draw and then the position on the screen that I want to draw it. And you can see here that I'm just calling a function just like you usually do within your C programs. This function, however, happens to be written by a different set of developers in the SplashKit library rather than the C or C standard library or a library that you've written. Then we delay for 5 seconds again, so we should see that string for 5 seconds. But what we'll find when we actually run this is that we don't see the string. And this leads to me to a bit of a concept that we talk about in graphics programming, which is called double buffering. And I'll talk a bit about it more later, but basically, anytime we actually want to paint something to the screen, we have to refresh the screen. And this is a really important step. And I think when I talk about it, the next set of slides, I'll talk a bit about why we actually do have this. So now if we compile this and run this, you'll see, hello everyone in 15. I've put 3 ones, I think, but that was a bit small, but you can see that pop up. So that's really, really cool. So we've created a graphics window. We're putting stuff on that graphics window. And then we're closing the window. So I think it's really important to take a quick pause here and talk about what's actually sort of going on when we use a library like this. And the other thing I wanted to talk about, because this is a bonus lecture and we want to sort of have some fun with it, but I want to talk about sort of the real magic of programming, in my opinion. The idea that we can build upon the work of decades of other engineers and developers and the efforts that they've made. So if you take this example here, this is basically what we just wrote and executed. And you can see here, for example, we've got a call to this open window function. That open window function was developed by some other programmers who designed the SplashKit library. And, you know, that looks like it's written in C. And then this is the actual implementation of that open window function, right? So within the SplashKit library, there's a bunch of C++ code that defines, you know, this is the code used to open a window. And the point of me showing you this isn't so you can understand it, it's to show you that all the different layers of abstraction that goes into writing complex projects like this. And you can see here there's another call to this function called skopenWindow, which is the back end of SplashKit. And if you look at the back end of SplashKit, you can see there's even more code. And if you're eagle-eyed, you'll see there's some calls to something called SDL. And what SDL is what sort of drives the engine of SplashKit. And SDL is actually a very well-known, it's called Simple Direct Media Layer. It's a very well-known project used as a game engine. It's actually used, it was used to create the original Source engine. So the early Valve games were all built on SDL. And you can see they've got a couple of examples. But you can sort of see there just the layers of abstraction and the amount of work that goes into something as simple as, you know, open window or draw text or something like that. So let's make something a bit cooler than just drawing text to the screen, right? So I had an idea for a project, but let's see how it goes. And you guys can sort of give me some feedback on how you think it's going. So another really important concept when we have games programs is that we don't want our games just to run for a set amount of time, right? 5 seconds, I mean, games would be pretty boring if you boot up, you start playing, and then they close after 10 seconds or 5 seconds or something like that. So what we do in games programming is we have something called a games loop. So that'll be the first thing that let's build here today. So let's just do it here. So a game loop is just a loop that doesn't end until the game should end, or the user tells the game to end, or something like that. And it's nothing new, it's just a while loop. We could just do while true so that it just loops forever. But actually SplashKit has some functions that help us SplashKit has some functions that can help us determine when the user probably wants the window to close. So the way we can do that is with a function called window close requested. Now, and then I think I just need to give it the title of the window. So we have this line here, while the window close has been requested, but that's not actually what we want. We want the loop to run while the user has not requested to close the window, right? And then this is it. This is our game loop. And so rather than just refreshing the screen once, we actually refresh the screen every time the loop runs. We don't want the delay anymore. We don't want to open a window every time, otherwise we'll have a lot of windows. But we just want to be refreshing the screen and drawing stuff to the screen in that time. Okay, so let's refresh the screen. Now we have another call that we need called process events. And what this does is it lets the user interact with the window. So if we don't call process events, the program won't be listening for the user when they click to close the window. And I think we should be able to just run this as long as I haven't made any errors, which looks good. And you can see if I go back to my desktop, you can see the windows popping up. You can see it's going to hang around for a lot more than 5 seconds. It'll hang around forever, basically, until if I click the close button, which is just, you know, the native button, then the program actually ended. It didn't just close the window. the program actually ended because this loop finished and we returned 0. Yeah, that's exactly right. So the 60, it's actually an optional parameter. You don't need it, but it caps the refresh rate. Absolutely right. So if we didn't have it, it would actually be processing events and refreshing the screen as fast as my CPU could handle it, which can be a bit problematic sometimes. So the 60 just caps it at 60 frames a second. Cool. So that's really cool. So we have a little games window. Now, let's write a function that can draw a random shape to the screen. So let's say, what parameters will this function need? Well, it's going to need to know where to draw this, to draw some shape, but it will decide what shape to draw and all of that stuff. Now, to make things our lives a bit easier, let's say we have a predefined width, so all the shapes are going to be the same width and height. We also need to determine the color. So color is a data type that is available to us from the SplashKit library. I'm going to call it CLR, and we have a little helper function here called random color that comes from SplashKit, which is really cool. So it's just going to return a random color, and I'm going to store it in a variable called CLR. Okay, well, let's just draw a shape to see what that looks like. So if I go full rectangle, fill rectangle will take that random color, it will take the X and Y that I pass it, and it will take the width and the height that I pass it. And so they're the 5 parameters that fill rectangles need. What color should the rectangle be, where should it go, and what's the size of it? Then I just need to call draw random shape. Let's see what happens if we just call it here. I think it's just going to call, let's just say I give it 50. It should just call, create a series of shapes in the same position. What have I done there? Equals random color. Oops, I didn't compile it. Cool. Now it should just create, yeah. So you can see it's going nuts here. So this loop is running, it's calling draw random shape. At 50, 50, 100, 100, it's drawing a new shape, a new rectangle, sorry. Where's my window gone? It's drawing a new rectangle, but the color is being randomized every 60 times a second, which is pretty cool. But we can sort of enhance that and make it a bit better, I think. So why don't we get a random integer. Now, R&D is, I believe, a function that also comes from SplashKit, but there's other ways to create a random number. So we're just creating a random number between 0 and 3. And using this random number, we're going to decide what shape we should actually draw. So if that random int is equal to 0, then let's fill the rectangle. So 0 is going to be our rectangle. And we can say, otherwise, if it's equal to 1, does someone want to give me a shape in the chat? We don't have every shape possible. But if I go fill, you can see we've got a rectangle, we've got a triangle. What else do we have? Ellipsis, circle. Yeah, that's all we've got. And then anything else has to be a lot more custom. So let's just keep it to those 4. So we just need to pick 2 more. I think we'll pick maybe a circle. Yeah, a circle's pretty good. Decagon. I don't even know how to start. Let's fill a circle. The color will also set it to color, so it'll be that randomly generated color. The X and Y, you want an ellipse? We could do it. An ellipse, so a circle only has a radius, it doesn't have a width and height. An ellipse has a width and height, so it can be like a malformed circle. But this should demonstrate it. And then we'll do one more statement. And let's do a triangle, because triangles are really tricky. Now, triangles always trip people up. So they actually take 7 parameters, and it's the color, and then it's the X and Y position of the 3 vertices of the triangle. And this is a good moment to talk about how we conceptually draw to a graphics screen in general. So give me a second here to open up a whiteboard. Too much light mode? Yeah, I know. I usually keep it in dark mode, but to take screenshots and stuff, I use it in dark mode. Okay, let's see. Okay, you should be able to see this whiteboard here. All right. So the triangles are really tricky. So let's sketch out what's going on here. So we've got our graphics window, with our 3 buttons here. And one interesting thing is that the origin point of a SplashKit graphics window, and actually this isn't a decision that the SplashKit developers made. This goes all the way back to OpenGL. So this is how OpenGL graphics windows draw. The origin is the top left point. So X increases as we go to the right, which makes sense, but Y increases as we go down. So this would be, 800, 400 in our example, and this would be 400, 0, and this would be 400. Sorry, this would be 0, 400, and this would be 400, 800. So if we want to draw a triangle like right here, given some X and Y position, we need to calculate these 3 points. So the first point is going to be X, right, plus half the height. And the Y is, sorry, no, that's the Y. And it's actually going to be minus half the height. And then the X is just going to be X, right? Because it's going to be like that. Hopefully you can sort of see that screen. Maybe if I draw like this, it'll be a bit easier. If we look at this bottom right point, the X position is going to be X plus half the width. And the Y position is going to be Y plus half the height. Because we're going, just my triangle's not drawn very neatly. For the bottom left position is going to be X minus half the width. And the Y position is going to be Y, we're going down, right? So it should be Y plus half the height. So let's get that into our code. So fill a triangle. Well, I should probably keep that up, right? Because it helped me figure out what to do. So there we go. So the first point, it can just be the top point. It's going to be X minus, we have to use brackets here, the width over 2, and the Y is going to be no, that should just be X. I got it confused again. Oops. X, Y minus height over 2. That's the top point. The bottom right point is going to be the x plus the width over 2. And the y is going to be y plus the height over 2. The bottom left is going to be x minus half the width and y plus, yeah, half the height. Okay, and hopefully I did that correctly. Let's make this a bit bigger. Let's compile this. Let's run it. Awesome. You can see here, I mean, well, sort of awesome, because the position of the shape is set. It's just drawing the shape over and over itself. But you can see there's triangles appearing, there's squares appearing, and there's circles appearing, right? Over and over. So let's try and fix up where the triangle gets drawn, or the shape gets drawn. So we could randomize that x and y, but something else we can do is to take, just like we take user input from the user's terminal, we can take user input from their interactions with that window. So where I draw this random shape, what I can actually do is only draw the shape, okay, if the user clicked the mouse and they clicked the left button. And then don't just draw it at 50-50. Let's draw it at the position of the user's mouse. So point2D is just a data type that has an x and y in it. So I've called it clicked point. So I can just pass in the clicked point's x. So hopefully you've spoken about structs before. Point2D is basically just a struct. So I click the mouse, I get the position that the mouse was clicked at that instance, and I pass that x and y to draw a random shape. Okay, let's compile that. There's an error there. Yep, that should be point_2D. Cool, that ran just fine. Let's compile it. Okay, so we get this graphics window with hello everyone in 1511, that's cool. And then nothing happens, which is sort of correct. And then hopefully if everything works correctly, when I click the screen, we get a random shape in a random color. And you can sort of see that is what's happening there. Which is pretty cool, I think. This is a pretty basic program, but you can see that there's no new concepts here. There's nothing unfamiliar to things that you've been learning. It's just using a different set of functionality. Do we have any sort of questions generally or specifically so far with anything that we've been looking at? Nope. Cool. So hopefully you can sort of see that, you know, just using these basic building blocks, and it's not just that we can draw shapes, we can draw bitmaps to the screen, animations to the screen. We can sort of create any sort of basic 2D game that we want. So let's take a moment to get a little technical. So how does SplashKit actually work? And of course, this is all bonus content. None of this stuff is designed for you that you should necessarily have been exposed to or understand. But I thought it would be just interesting to talk about a project like SplashKit and how it works. and what's going on underneath it. So SplashKit is completely open source, cross-platform, and cross-language. So you can actually view all the source code on GitHub. I can send you guys a link to the GitHub if you're interested, and to see how it all works. It's cross-platform, so it works on Mac, Windows, and Linux. But the really interesting aspect is that it's cross-language. So I'm writing some C++ code here, but SplashKit also supports Python, Java, I think, Pascal, I think, so a number of languages. So SplashKit, what it is essentially doing is it's wrapping these fundamental major libraries, something like SDL. It wraps other libraries like SQL, so you can create databases in SplashKit, libcurl for networking and things like that. And then it generates this SplashKit backend library. Then SplashKit has a translator layer that takes that backend library, which is written in C, and using a custom language that we write in the header docs of the SplashKit library, the SplashKit translator can take that source code and generate a version, an API to that source code in any destination language that it's pre-configured for. So then when we're programming in something like C for SplashKit, we're not actually programming against the core API, we're programming against an external API that wraps that function. And then you notice I was using something called SKM in the terminal. That stands for the SplashKit Manager. And so basically what you'll see shortly, I think next week, potentially in 1.5.1.1, is that when you're compiling multiple programs and libraries, you need to link those in and support the C compiler to achieve what you're trying to achieve. And the SKM, or the SplashKit Manager, is assisting with the build process. And then I thought in the last portion of the presentation is I could talk to you about some of the games that have been created with SplashKit, and I'll even show you what the source code to a more complex SplashKit project actually looks like. So here's one called Cave Escape, which is basically a Flappy Bird clone. And you can see the 4 iterations here that I'm showing. So how you can just start by drawing something to the screen, drawing multiple things to the screen, building up an environment, and then building the logic for it, and then you've got a game. This is another project that was developed in SplashKit called Demo City, and it's like a Sim City clone, basically. Because the key thing to know about SplashKit, it's an education first tool. So it's designed to teach the concept. So it's not an industry game engine. And then a couple of other examples here. So to finish off, why don't we look at the source code, the iterations of the source code, compile and run the Cave Escape game, which is a really, really fun project. So let's go to my desktop. And then in my desktop, I've got this, whoops, cool. Yeah. I've got this Cave Escape directory. We can minimize this whiteboard. And so, like I mentioned, all of the iterations to the Cave Escape game are pre-written here, because we don't really have the time to build something like this from scratch. But you can sort of see how if I look at the first iteration, and I'll actually run it, so SKM compiler, Cave Escape 1.c. This is a CPP file, but it's just C code here, really. And I just call that Cave Escape. If I run Cave Escape, whoops. You can see here that just like earlier we saw, I'm opening this window. I have a loop here that will quit when the window has been requested to close. I'm refreshing the screen and I'm processing events. So there's nothing here new that we haven't seen before. If I look at iteration 2, you can see how we're creating some functions, like a function that can create the player. The player in this case is actually an animation of this, like, I don't even know what it is. it's like a fly sort of thing. So if I compile iteration 2, and actually let me just go and I run it straight away. Oops, it looks like there's some, I don't know where that 0 came from. Cool. So if I run that, you can see we have this cute little thing flying on the screen. So that's an animation that's playing on a bitmap and running in a loop. I'll do one more sort of sequential iteration, then we can just jump to one of the later ones and play around with the source code a little bit, and then happen to answer any questions if we have any. But so here we go, is now we're applying, so SplashKit, other than graphics and things like that, has some physics logic. So it has a way it can set the velocity on a particular item. So if I compile the third iteration and run that, you can see the character has a velocity applied to it, so we're simulating gravity, and the player just falls off the bottom of the screen, which is pretty sad because we can't get him back up. So then you can sort of see how, okay, the next thing we need to do is add a way to get him to jump up, but then we need to add the obstacles, and so he can fly through the obstacles. So if we jump right down to, let's just jump to the last iteration. You can see the fully finished Cave Escape game. I'm not sure if you can hear the audio because it's really loud in my ears. I don't think you can. But the audio is really cool actually. But here we have the Cave Escape game, and I'm just hitting spacebar to jump, just like Flappy Bird. And then as these obstacles appear, we go through the obstacles, and you can see in the top left there's a counter. Whoops. There's a counter for the amount of obstacles that we can get through. And then if it intersects with another object, the game resets. So that's what's causing, like if I hit the roof, for example, as well, or if I hit one of the poles, the game quits and resets. And so you can see the final version of the Cave Escape code here. You know, a bunch of type def, so we're creating some structs, basically. We have some functions that can help us do what we need to do. But really, that project is just only just over 300 lines of code. So it's not even a huge game to create. So you can see SplashKit's giving you a lot of useful functionality for creating these things. But you can focus on the concepts and create cool programs. So I think that's all I sort of had scheduled to talk about for the bonus lecture this week. But I don't know how many of you are actually tuning in live, but I'm more than happy to take any sort of questions you had about the project or the presentation or the code or anything like that, or just any questions about software engineering in general. Otherwise, I'll wrap it up there. But yeah, please, any questions, guys, let me know. We can have it running in the background because it's cool. No, quiet stream. Oops. What would be the best platform to start a basic personal project? Do you mean using SplashKit or sort of more generally? I'll come back and answer you when you follow up. But what kind of things do I normally code day to day? Great question. Very good question, Nicholas. So previously, in my previous position, I was a what's called a research engineer or a research fellow. So I was writing Basically, I was running a lot of Python code because I was working in AI and data science. So we're using a lot of the data science libraries and things like that. So I was writing a bunch of Python. Now in my current position, which is I'm a lecturer here at UNSW CSE, so I'll write either some code maybe in the unit that I'm teaching, but I also manage an open source system called Doubtfire. So I build that. That's a web app, so that's TypeScript in the back end, Ruby in the front end. But then also I built SplashKit with some other amazing people over the past 10 years. I haven't worked on it for 10 years. The project's been going on for 10 years. I've contributed to it. And so SplashKit's written in C, C++, and then translated to a number of bindings. So yeah, I work on interesting stuff like that, SplashKit, Doubtfire, or stuff that I was doing in my research work. To make a small game for learning, so I know it's a bit of a plug. So you can go to splashkit.io right now, or whenever you want, and you can install SplashKit. You can follow all the articles and guides. You can pick your operating system, and you can just follow the installations and then pick the language that you want to write it in. And you can just start using SplashKit, which is cool for you guys because it's just using C, C++, which is what you've been learning so far. And I think SplashKit is cool, obviously, because I helped build it. But there's many, many other game engines that are really, really cool. I think early on, like you mentioned, you want to learn it for learning. Don't go into stuff like Unity or Unreal. Those are really productivity engines designed to build like AAA games. They're not designed for you to understand necessarily how a game engine works or how programming for graphics works. They're made to be really productive so you can make money. So they have a lot of things for assets and all of that stuff. So I think go something really, really simple. I think Pygame is pretty good for Python. So I think stick with 2D, although it looks like Pygame has some 3D stuff. I think stick with 2D for getting into it. So I'm sure they have plenty of 2D stuff. Stick with something simple. Pick your language. Any language will have a basic 2D game engine. SplashKit's a cool one. Pygame's good. Ruby game is somewhat interesting. So there's a bunch. Pick your language that interests you. Maybe you want to pick up a new language. And then find a simple 2D game engine that doesn't hold your hand too much, but also that doesn't, like that it's not like drag and drop and stuff like that. So you don't want it to be too education focused. And so that's really why SplashKit was designed. So we felt that some game engines like do way too much for you, so you can't actually learn anything. And then the education ones just do nothing. Or it's just too one side or the other. So SplashKit is designed to be in the middle. But yeah, definitely like make a game. It's really fun, and you think about programming in a different way than if you're just writing something to the terminal. How do I make my keyboard sound like yours? Spend way too much money. Yeah, a sickly amount of money. No, it wasn't too bad. It was my lockdown project, actually. So I lubed all the switches and got busy doing that. And there's also a bunch of articles on the SplashKit website for how to do certain stuff. So if you go to starter, you can get started drawing shapes to the window, which is sort of something we lightly covered today. We talk about double buffering here, which we didn't actually talk about today, but that's fine. That's why we have the refresh screen, things like that. Bundles, reading text, networking, so you can create two-player games that operate over the internet even, or just over the network. Databases, so you can persist data, create like a... You can see I wrote this article. So you can create like a high scores database so that every time someone plays your game, the scores get stored in the database, for example. So you can do a bunch of different things with SplashKit. But find something that's interesting to you. It might not be games. and create projects. And the more you write code, the better you'll be at it. And then you'll be really happy. So cool. Any last questions? If not, it doesn't seem like there are. Feel free to reach out to me if you're interested in anything like this or just have any other questions. Sasha can share it, or I'll send my email in the chat, and I'll also send the website to SplashKit. So you can go check it out. What got me interested in programming? I don't know. I always liked computers. I think because I didn't get one until I was a bit older. So we never had like a family computer. And then when I did get one day, I thought like, oh, these things are cool as. And then went through high school, took a software development the class in high school, but I knew I wasn't actually understanding anything there. And so I just knew I want to do something with computers. And whatever I want to do something interesting. So computer science sort of made sense. Went to uni, studied computer science, and obviously there's a lot of programming in computer science. So, but I just was always interested in it. I don't have a great answer for you. Maybe because I was sort of so young when I decided to go in that path. But I think what keeps me interested is, what I spoke about earlier in the presentation, when building upon the shoulders of giants. I think that's just the coolest thing, that you can download the SplashKit library, call a function, and then that calls a function that I wrote, and that calls a function that someone else wrote, and that calls a function that someone wrote at SDL, and that calls a function that someone wrote in the Microsoft operating system, potentially in the 70s. And it all works, and then those pixels get drawn to a screen, and that screen refreshes at insane rates, at insane DPIs, and it all just works. I think it's just such a cool, when you take a step back and think about it, even if you just draw text to the terminal using the C standard library, there's so many layers there. The hardware, the chips, even getting your computer shipped to you, like there's just so much that goes into it. And to be able to write programs that people use is super interesting, and keeps me motivated. So yeah, keep building programs, and eventually you'll start building stuff that people use. And that's what's really addictive, I think. Cool. Well, still got 7 minutes. So if you've got any more questions, feel free. Otherwise, Sasha, you can decide to call it if you're still here. I'm not actually sure. Or I can probably end the stream on my end too. I'll post my email. So you can email me if you happen to have any questions. But no, thank you guys for coming. I know it was early and it's on your study break and it's an optional lecture, so I really appreciate. Thanks, Sasha. I really appreciate you guys all coming, and hopefully, maybe at the end of the trimester, when you've got a bit more time, do something like create a little game. Don't go crazy, but create something, see something on the screen. I think it's really cool seeing something graphical. And I will say, actually, as the last comment, a really, really interesting project. If you can build Tetris, that's a really, really interesting project. There's a lot of interesting stuff that happens there. And then you go in to start reading what are the actual game rules of Tetris, and they're actually quite complicated. So if you're really keen, I really recommend pick up something like SplashKit. It doesn't have to be SplashKit, and build Tetris one day, and you'll learn a lot. I promise. Yeah, Tetris is hard. Yeah. I've got a SplashKit Tetris game somewhere written in C# though, but it is somewhere on my computer, but it's a really, really fun project. And it's a fun game. Like, I'm building it and I'm just stuck playing Tetris for 20 minutes. How do you even score Tetris? I don't know what the official, isn't it? Because the speed increases. And like as the speed increases, the score increases. I think it's just like that. Oh, it'd be a cool assignment one. I guess you could just do it in the terminal. But the really hard stuff about, I think like the hard stuff with Tetris is like rotating a block and determining if it can actually fit. Because proper Tetris, like you can, I don't know if there's any, the official rules, like there's some official rules that like you've got to, when you rotate the block, even though it might clash, the rules say that, okay, you've got to actually rotate it twice to potentially fit it into a nook. So you can do like tricks, but you got to program that all in. It's a line clearing. You're right, Nicholas. Yeah, you're right. From memory, the scoring wasn't the hard part. It was like the rotating, not the rotating on its own, but the rotating to do like tricks. Thank you for not choosing Tetris. Yeah, it's a bit rough for a 1511, I think. Maybe in the next version of the unit or something. The following unit or something. But it is really though, it's one of those projects, it's one of the few projects that I've worked on. And then after I work on it, I definitely felt like I learned something, or that I felt like it was a really, really interesting project. And those are the really good projects to work on. Way too are you. Gordon's tuned in. This is not Sasha. I've overthrown Sasha. No, it's this is the study break bonus guest lecture. So maybe if you go back and watch the video, you'll see. But Sasha's in the chat, of course. Sasha invited me to be here today. But anyway, that is what I've got. So again, feel free to reach out if you've got any follow-up questions. And good luck with 1511, the rest of the trimester. Enjoy your recently granted freedoms in Sydney. And I'll see you all around. Perfect. Well, Sasha, you can end it right now. Or you can overthrow me so that Gordon has some comfort in seeing Sasha back. Obviously, they miss you, Sasha. So that's really good. All right. Thanks, everyone, for coming. Have a really good day, and good luck with study break and the rest of the trimester. See ya.